My name is Rene Peters. I was in Shell for some years. After that, I went to TNO, and I'm 20 years now in TNO working on gas, or broadly, in a broader perspective, energy. But in practice, it's about gas. And I spent about 15 years in upstream oil and gas. A few years on shale gas. That's where we met when you were writing a book. And then green gas, synthetic gas, and over the last years, suddenly hydrogen have come up. And hydrogen relates, I think, to the topic that I will be discussing about, because over the last 10 years, the oil and gas companies were asking us, as TNO, as an applied technology organization, how can we get the last drop of oil or the last molecule of gas out of these reservoirs in the North Sea or onshore? But the last, let's say, 4 or 5 years, the question changes into what is our future if oil and gas is actually depleted and the fields are empty? And is there a future role for the oil and gas companies in the new energy system? And can we make use of the existing assets that we have in the North Sea for the future energy system? And hydrogen could play an important role in that. I'll come to that. So my talk is about the energy transition accelerator North Sea, because I think looking in a broader perspective, in a system perspective to the North Sea and the assets we have, we can accelerate the energy transition. And there is definitely a position for the energy companies of today in joint collaboration with the energy companies of tomorrow. I will give a little bit of an introduction on oil and gas in the Netherlands. We have Japanese visitors here today, so probably you're not all that aware of what's going on. So I'll dive a little bit on the history and then move towards the future and the value of system integration. So the North Sea has always been a very important area for energy for the Netherlands or for Northwest Europe. Producing gas. We found offshore gas around the 70s, these small green pockets, those are the gas fields, and we found many more over the next decades. And around 1980 we started to develop these fields to produce offshore gas with a few offshore pipelines to shore. And that expanded over the years. We have now, I think, over 250 fields identified for natural gas and a few of oil, the red ones. And we've built a vast network of pipelines to transport all that energy to shore. Of course, this is the big Groningen field you will recognize. Actually, not everybody probably knows that we also host one of the biggest oil fields in Europe. It's the Schonebeek field. It has about 1 billion barrels of oil. But unfortunately, it's very heavy oil, so it's difficult to produce. But we are very rich on oil and gas. And also a lot in the offshore environment. But the offshore fields are depleting. This is the production profile of the small fields, not only offshore, also onshore. And actually, and it's not only because of the small fields are depleting, but also the Groningen field, of course, is closing. We have become a net gas importer in the Netherlands, while we have been a big exporter for Europe over the last decades, as you probably know. And if you look at the further decline of the production from these small fields, it means that offshore production will stop around 2040 in the Netherlands, unless we explore more oil and gas to expand that a little bit. And we're talking about a lot of energy. You should realize that every billion cubic meters of gas, or 20 BCM, which we have been producing last year, is equal to 700 petajoule of energy. That is huge compared to what we are installing on renewable energy, for example. The biggest wind park that is built, a gigawatt of wind, produces about 10 petajoule of energy. So 700 petajoule is about 70 of the biggest wind parks which are there in the offshore environment. So it's a lot of energy. The oil and gas infrastructure in the Netherlands, these are the wells which are still in use, half of them onshore, half offshore. These have been shut in. We have about 3,000 in the Netherlands, about 150 platforms on the North Sea, and there's about 3,000 kilometers of gas pipelines to transport all that energy to shore. And we still have quite some reserves, some 100 billion cubic meters. If you look at the gas infrastructure, which are all the pipelines which connect the platforms and the fields to shore, you see there are, well, there's 3,000 kilometers in total, but there's a lot of big trunk lines who transport the energy from many platforms. These are the red ones, basically two main locations. One is Den Helder and the other one is Groningen, and a few smaller locations over here. And it's very interesting to think about what is the potential for future use for these pipelines, because they're now used, of course, for gas transport, but in 10, 15 years they will not be needed for gas. And is there an alternative use? Think about CO2, think about hydrogen, and is it interesting to develop them in combination with offshore wind conversion to transport all that energy to shore? But then look at what is happening to the platforms and the infrastructure, because if the production of gas stops, the oil and gas operator has to decide within 2 years what the future will be of this platform. And if there's no future function, it will have to be removed, which means that the red line is the installation line. We have about 220 platforms installed and still 150 in use. But in the next, let's say, 5 to 10 years, most of those platforms will have to be removed because the gas is basically stopped. And if there's no other function or no other use for these platforms or for the pipelines or for the reservoirs, all the assets will be removed at a cost of about 5 to 7 billion euros in the Netherlands only, about 100 billion euros over the rest of Europe. And of that, about 70% is socialized cost. So it's not only cost of the oil and gas operators, but 70% is paid by the government via their shareholder EBN or via fiscal measures. So there's also a social reason to reduce these costs or find efficient reuse of this infrastructure. And otherwise, the ship will come along. This is one of the biggest ships in the world, built by a Dutchman, Allseas. And it's taking away these platforms just in one go, one day, and it will take away not only the topside, but also the substructure on the back of the ship, as he has already done it for the Brent platform in the UK. At the same time, as gas production is in decline, you see an exponential increase of offshore wind in the North Sea. And the North Sea is actually a pioneering area for offshore wind, as you probably all know, with vast ambitions to expand the capacity, not only in the Netherlands, also UK mainly, Germany, Denmark, of course. And that means that in the future, much more space, marine space, will be required to put all the offshore turbines in place. And at the same time, we are declining gas and make space available, of course, for offshore wind. But there's very little space in the North Sea. Probably if you are at the North Sea, you think I see only water, so there's enough space. But in reality, all the space is already claimed for certain functions. Of course, I talked about oil and gas, the current wind and plants which have already reserved space. The offshore infrastructure, which is of course at or below the seabed. But there's many other functions in the North Sea, like shipping, like sand production, like marine testing. There's a lot of other activities, even Natura 2000 ecology preserved spaces, which limit the area for expansion of offshore wind. And it's not the only challenge we have to introduce renewable energy. We also have big challenges related to getting all that energy into the energy system. Because as we know from solar and wind, the energy is intermittent and it's more driven by the weather and by the climate rather than the demand. So the whole capacity and stability of the grid is becoming a big issue if you start introducing vast amounts of wind energy into the system. Of course, we need to drive the emissions down, not just CO2, also other greenhouse gases, methane, NOx, SOx. Limited marine space, I already mentioned it. And also we have a lot of assets in the North Sea. Think of all the pipelines, all the platforms which have no function anymore for gas. So the challenge that we're facing is, have these assets any value in the future energy system? And can we make use of it in the new energy system to solve parts of these problems, and in particular this one? And in this energy transition, it's often positioned as stopping with grey and starting with green, or stopping oil and gas and starting with solar and wind. But that's only part of the story, because it's a transition. It will take 10, 20, maybe 30 years before we move from a grey system to a green system. And in between, there is a transition which is decarbonized energy, and we call it blue. Decarbonized energy is energy still based on oil and gas or fossil fuels, but it's decarbonized. Decarbonized by capturing the CO2 and storing it, or intermediate solutions. And for all these energy sources, we need the North Sea, because we need the North Sea to store CO2. We need the North Sea to produce renewable energy from wind. And we will also in the future potentially use the North Sea and the empty gas fields to store energy or balance the energy system. So the North Sea is a very important area where the energy transition in the Netherlands is occurring. And to get this system and this transition going, we need system integration, and we need collaboration, because integrating different systems based on electrons or based on molecules needs collaboration, looking at an integral approach. So what we did 2 years ago was bring the wind sector and the oil and gas sector together to discuss the challenges of the future and how there could be value in working together, also together with branch industry and NGOs, to look at where's the potential for synergies between oil and gas and offshore wind in the North Sea. And we realized it's not just oil and gas and wind, it's also the society who plays an important role. For example, because they pay most of the costs of removing the oil and gas assets, but also installing wind. Because wind itself, it's now subsidy free, but it's not the connection to shore. That's still paid by the community. That's all the tenant installations, the cables, the transformer stations. That's a lot of money. So how can we make an integral system of the North Sea to reduce emissions, to keep a license to operate in the North Sea, to make efficient use of spatial space, but also to keep activities in the offshore sector where the Netherlands is strong in and has a strong economic value. So we developed the North Sea Energy Program, which is a program with many partners collaborating in offshore wind and offshore oil and gas. We look at strategic planning, we look at the societal and governmental aspects, so legislation, policies, physical networks, combining and linking the electric system and the gas system, but also look at, of course, safety and emissions and environmental impact. So we've run this program already for 3 years. The first results can be found on this website, and you see the sort of topics that we are working on. It's not just the technical part, it's also the regulatory framework which is needed to make this transition happening, and of course also the economics, because if there's no economic case, then nothing is going to happen, at least not from the business side. So we developed an energy atlas to analyze all the assets which are in the North Sea related to offshore wind and offshore oil and gas. And this is the southern North Sea, so it's the Netherlands and the UK. And what you already see is that the areas where there's offshore wind planned or being developed, those are areas where there's pipeline capacity. So there's connections between offshore, well, there's no connections yet, but at least there's an overlap in assets. And all these dots are existing platforms, which sometimes are quite nearby the offshore wind developments. So there might be a potential for integration and combination. And we worked with these partners to look at the options and basically found 5 main options for integration. The first one is these offshore gas and oil and gas platforms need a lot of energy to compress the gas, to produce the gas or the oil. And that is being produced by burning gas, which is not a very efficient and very clean way, while at the same time there's a wind park being built nearby. So the connection between offshore wind and gas can reduce the emissions on the platform. It can create a zero emission platform basically. Power to gas is a nice way to convert electricity into molecules, hydrogen, by splitting water into oxygen and hydrogen. And that could be done on platforms to actually reuse the existing pipelines and transport the energy not via electric cables but via molecules in the pipelines. Carbon capture and storage, CO2 storage, it's reusing the existing pipelines but also reusing the empty gas fields to store CO2, which is needed also to bring the hydrogen economy started, and then I'm considering the blue hydrogen economy. Gas to wire, that's actually the other route. It's to burn gas from stranded fields to produce direct electricity and feed it into the electric grid, which is not fully used with offshore wind. And the last one is large-scale energy storage by using the empty gas fields to store energy. Could be on the form of hydrogen, could be in compressed air energy storage. So we're working with the partners to look at the technical, economical aspects of it. Can it be done? Is it economic? What are the legal barriers? What should be done to make this happen? And on the electrification, if you look at the platforms which are currently on the North Sea and are using power, at the moment about 500 megawatt, you see that a lot of power is used in these areas where actually the new IJmuidenver wind park is planned and being built. So there's an interesting potential connection between the platforms which use a lot of energy and the wind parks who are producing clean energy. And a few operators are considering now electrifying their platforms from offshore wind. Well, this could be from shore as well, from a cable brought from shore to the platform. That's already happening at one of the platforms of Neptune. It could be by producing clean power on the platform itself with solar panels or a small wind turbine, or it could be by developing a big offshore grid which connects all the platforms with wind parks which are under development or back to shore to connect to the local grid. CO2 storage is being discussed already for many years. It was always difficult to get a project going, also because of public hesitation and opposition. But there's a change in thinking because CO2 and CCS was always linked to coal-fired power plants. You capture the CO2 from the flue gas and then you store it and you keep the coal power plant going. But now CO2 is much more linked to hydrogen. And then in particular blue hydrogen. Blue hydrogen is the hydrogen produced from natural gas, but there's a lot of CO2 produced, and if you capture the CO2, you produce decarbonized hydrogen, and if you store the CO2, you actually stimulate the development of the hydrogen economy. There's a lot of empty gas fields where the CO2 in the Netherlands could be stored, and together with industry we're developing a roadmap to stepwise develop these CO2 storage options for the Netherlands, and on the longer term maybe even shipping towards Norway or the UK. Gas to wire, this is to actually maximize the recovery from stranded fields. We look at it for the Netherlands. Well, there's not much stranded fields in the Netherlands, at least not those close to an offshore grid. But on the UK side, they also looked at it and found that there could be very much potential for that, because the UK system is different in the density of the electric grid. And they identified some 16 options for gas to wire in the southern North Sea on the UK side. And they're continuing this option further. And then this one, which I think is one of the most promising one for the future. This is to bring the offshore wind energy to shore, not in the form of electricity and cables, but in the form of hydrogen. The idea is that the electricity is converted on the platform into molecules and then transported via the existing pipelines. And that's where the benefit is. You use the existing infrastructure. You don't have to install new cables, new transformer stations, new electricity infrastructure. You actually reuse the existing assets. But of course, you have to convert the energy. That also costs energy. And there's a certain distance from shore where this one is beneficial compared to conversion onshore. Because basically you can have conversion onshore, you can have conversion on the platform, you can even have conversion in the turbine itself. I don't know if this was covered by the training, but there's a Dutch turbine manufacturer who is also working on direct hydrogen production from the wind turbine and then bringing it immediately to shore. So there's no cable from the wind turbine, but there's a pipeline coming from the wind turbine. And then you produce hydrogen directly to shore. We did a few calculations on volumes. So if you could convert all the energy which is produced from offshore wind into hydrogen, and you realize that you need about 55 kilowatt hours of electricity to produce 1 kilogram of hydrogen, then you find out that for one wind park, which is 700 megawatt, 10 petajoule, you can produce about 80 kilotons of hydrogen. And that's about 10% of the current Dutch use of hydrogen. The current use is about 800 kilotons. That's the current market. So if you look at the buildup of offshore wind in the Netherlands, so you would convert all the energy into hydrogen, even in 2030, we would still produce not more than the current existing hydrogen demand in the Netherlands. But it would all be green hydrogen in this case. So actually, if we want to speed up the hydrogen economy in the Netherlands, we also have to speed up the offshore wind development, because we need a lot of green energy to produce green hydrogen. And the plans are quite diverse. This is a PBL scenario, slow scenario, and a fast build-up scenario, moving towards 60 gigawatt in 2050. And in that scheme, we could produce about 6 megatons of hydrogen per year, but we need to convert all the energy into hydrogen. While at the same time, we need this power, of course, also for mobility, for heating, for all other. If we close down 5 coal-fired power plants, we need all this energy to convert the green power into green, the grey power into green power. The last one to mention, which is also of interest, and I'm nearly there, large-scale energy storage. I mean, the future energy system needs a lot of balancing of the grid, because there's intermittent production, there's varying demand, and it doesn't match. So we need a lot of balancing, seasonal balancing, but even during day and night. And hydrogen is an excellent way to store a lot of energy. That can be done in salt caverns, but it could also be done in depleted gas fields. There are some challenges to be solved, but one way of reusing the old empty gas fields is store energy in the form of hydrogen. So how do we see this in time? We are still conventionally producing oil and gas. We will move to electrified production, which is a zero-emission system. Carbon capture and storage is on the brink, at least for the Netherlands and the UK, and Norway, of course, has already CCS ongoing in the next 5 to 10 years. And thereafter, we expect hydrogen to come into play if we have sufficient green power from offshore wind. So this is a trajectory over the next 20 years, and that's exactly the period where oil and gas will be reducing, so it could fit in time as well. And then on the longer term future, we will have things like this, the offshore energy islands. TenneT has come up with a proposal to produce an island that was only on electricity, and we think hydrogen should be part of this play. So we will have an energy island which will collect all the wind power energy on the island and then distribute the energy via cables or via hydrogen to the North Sea countries around it. So the future energy system in the North Sea, which will be much more complex than it is today, it's much more an integrated system. It's not just the wind farm producing electricity to shore and the gas platform producing natural gas, but we will convert wind into hydrogen, produce it to shore, store it. We will produce CO2 from shore to the offshore storage sites, which needs power from the wind parks, and we will also drive electricity to the platforms to make them a zero-emission production site. So how does it look in time? Well, we are now, of course, still on the grey hydrogen. We're starting to work on CCS. We're doing concept studies. I expect blue hydrogen will come in first. That's where we also need CCS, CO2 storage. There are some projects already in the Netherlands, in Rotterdam, in Groningen, to start with blue hydrogen, with nearshore CO2 storage, and we are starting electrification of platforms. And in the next 5 to 10 years, we will see the start of green hydrogen produced from platforms. We have already announced the first pilot, a 1 megawatt unit offshore The Hague, to start with green hydrogen production from an existing live oil and gas platform. And then initially we will admix the hydrogen to the gas stream, and later on, if the volumes increase, we'll have pure hydrogen transport, and of course ending up in the nice energy island with green hydrogen production, large scale power to gas, and hydrogen transport and storage maybe in the North Sea. And that's, I think, the last vision. This is not just the Netherlands, this is the whole of the North Sea. because we're talking about the Netherlands now, but of course this picture should be expanded to the whole of the North Sea. UK is looking a lot into CCS. They're looking into gas to wire, and they're also looking at power to gas and hydrogen. The Norwegians are very much looking into CCS. They're working on floating wind a lot. And you see the infrastructure in the North Sea is combining and connecting all these energy areas. So the North Sea will stay very important for the energy, not for the fossil fuel energy, but for the renewable energy, and also the storage of CO2. And that's the future of the North Sea. And I'd like to thank our partners who are collaborating in this program. I'd like to make this final statement. Offshore system integration, winning plus wind is wins, in Dutch.
Well,
it doesn't work in English.
Rene Peter.
Okay.